Okay, we're going to be talking about taking the integral of a function, and we're going to be using u-substitution is going to be our method. So we've got the integral here of x plus 1 quantity squared. Now you could full this out and work it out the traditional way, but we're going to do what's called u-substitution. So we let what's in parentheses be our u, and then we take the derivative of this and we get du is equal to 1 times dx. Now normally you'd see du over dx, but we're taking the dx up over here. Now we're going to do the substitution part. So u being the x plus 1, we just substitute it in, and of course it's squared, and this is du is equal to just dx, and so where there's a dx we replace it with du, and we have our new integral. And so now we just take the integral of this, so we add 1 to the exponent and put the exponent down below and plus our constant. Now we're not finished. We must now go back, since we started with x's, we now must go back and plug in, and our final problem here should be all in the variable x. So we take our u, which is x plus 1, and we substitute the u now for the x plus 1, and it's cubed over 3 plus c. Okay, so we've got the integral of 2 over the square root of 2x minus 1. Now we're going to be doing u-substitution on this one, so usually what's in parentheses or under a radical sign is what we're going to let be our u. We take the derivative, and the derivative of 2x minus 1 is 2dx. So now we're going to do some replacing here. So the 2 and the dx is going to get replaced with a du, and there it is. And the u, which is the 2x minus 1, right, is going to be replaced with a u. And so now I'm going to rewrite this, making sure we get it out of radical form, taking it up into the numerator. So now we add 1 to the exponent. That gives us a half, and then we take the exponent and put it down into the denominator, plus c. Take this 1/2 and flip it. It becomes 2 over 1, which is just 2, and this is u to the 1/2, so I write it back into radical form, plus c. Now remember, we started with x's, we have to end our problem with x's, and that means we need to go back, and our u, remember, is 2x minus 1. So we go back in where u's at, and we put the 2x minus 1, then plus c, and we're done. Okay, so we're finding the integral of 2x e to the x squared, so we've got an exponential function in here, and what we're going to let be u is what's up here in the exponent of e, which is the x squared. We take the derivative, we get 2x dx. Now we do our change of variables. We're going to change the 2x and the dx and replace that with the du. So we write the du here, and then we have e to the u, which is our x squared. And we have to note and remember this, that the integral of e to the u is just e to the u, and then remember we plus c it on the end, and then we go back and change, do our substitution where u is equal to x squared, and we're done.